Thank you, Laura, for that introduction, and thank you, everybody, for attending. It's a pleasure to be here, and I'm Stan from Michaels Energy. I'm the Director of Thermal Energy Consulting, and I'm going to speak to you today about thermal batteries, and I want to demystify, and by the way, I'll be speaking about thermal batteries in use basically for cooling loads across the U.S., and when I talk about cooling loads, I'm talking about HVAC and refrigeration. My colleague, Bruce Lindsay from Train is going to be talking about generating heat from ice using ice storage. And so I'll begin first with a brief introduction of what a thermal battery is. We're talking about ice storage, and some of you may be familiar. Ice storage has been around for over 30 years. And a quick example of ice storage, take a hospitality building, 600,000 square foot, very high-end building. And you're putting ice storage tanks basically in the basement next to the chiller, and you're making ice at night during off-peak period. And then during the peak period, you're turning off the most energy-intense usage in that building, which is the HVAC system. And you're basically riding through peak period, and you're reducing the demand during that period, the dirtiest part of the day, if you will. And then, of course, at night, you're recharging those batteries by making ice again. So it works that way in buildings, whether it be HVAC or refrigeration. Refrigeration is very similar. There's ice being made at night. However, it's not with pumps and heat exchangers. We basically have a passive product that hangs in the space very high up inside of a cold storage facility or on the ceiling of a grocery store, and we turn off compressors during the day, during peak period. Cold air falls, and we hold the temperature. Okay, it creates temperature stability. We can do that for up to 8 hours, and what we're doing is we're, again, reducing the peak and helping to manage demand. Now, the 44 gigawatts, let me tell you what that is. That is the amount of energy intensity across the U.S. grid for refrigeration. Refrigeration is a very large load. I think it's underrated, frankly. And, if I compare and contrast that with for example, office buildings, 21% of all office buildings in the United States are chilled water air conditioning, and that's roughly about 24 gigawatts. Okay, so energy intensity wise, refrigeration is a very intense load. As a matter of fact, per cubic foot, it is the most intense load on the grid. Next slide, please. I'm going to talk to you about the U.S. grid just here briefly. This is a graph that came out of a document called VPP Liftoff. If you're interested, go to the DOE website and look up VPP Liftoff. You'll find the document. And the DOE has determined that we are now in a period of load growth. Okay, now look at that graph and look prior to 2023. We've been in a flat load profile across the U.S. for over 20 years. We are now experiencing load growth principally caused by electrification of buildings, penetration of solar and other renewables, also electrification of vehicles. And the third big one really is data centers. Data centers are growing rapidly, and they are a big user of peak load. And so that's what's really driving the bus here. And you can see DOE is projecting roughly a terawatt by 2050. I think that number is low, frankly. And today, right now today, behind the meter, we have storage. We have roughly 60 gigawatts nationally. DOE is projecting that we need 160 gigawatts of storage. That's a big number. And I started to wonder to myself, why is that number so big? And my answer to that question is, if you think about it, we're in an energy transition. That transition is we're eliminating fossil fuels. Think about coal, think about gasoline. They're inherently storage. They are energy storage mechanisms. And what are we doing on the grid? We're putting up generation. Are we putting up generation in proportion to storage? Because if we're not, are we really replacing what fossil fuels do? And I think that is something that is causing stress on the grid as well. And so that is the problem that we're facing here over the next 30 years into 2050. We're going to be experiencing a lot of load growth, and we have to manage it. Next slide, please. Now, thermal batteries, and how do these fit in? Well, thermal batteries, as I mentioned, they've been around for flexible load management for over 30 years. Their time has come, and the way we think about this in the thermal energy storage industry is thermal batteries for thermal loads and electric batteries for electric loads. They're both important, okay? And they have to be applied differently based on the situation. And so from my perspective, thermal batteries are extremely low cost. I'll talk about that later, but they avoid expensive upgrades, T&D investments. They avoid, and there's no need to ever build another peaker plant. For goodness sake, we have so much technology out there right now that we can do instead of a peaker plant. No need for anything like that anymore at this point. And this building that you see in front of you is a cold storage facility. This is a 500,000 square foot cold storage facility. The load of that building, we can take that load during peak period, roughly 3 megawatts off the grid. That's a significant load, and we can do that for up to 8 hours. The nice thing about this type of facility and also manufacturing facilities, you very often find them in disadvantaged neighborhoods. Now, you know about the IRA tax credit. It's 30%. Train's technology, our technology, it qualifies for 40% because it's made in the U.S. And in certain disadvantaged neighborhoods, you get an extra 10%. You can get up to a 50% tax credit with this technology. That's very important to understand. It's really changed the game in terms of implementing this technology. It's dispatchable. The technology is dispatchable. It can be used with demand response. It can be used with real-time pricing and other grid services as well. Next slide, please. I wanted to talk just for a moment about the global cold chain. This is not something that's commonly understood. And as I describe this, think GHG. Okay, so if you had lamb last night for dinner, it may have came from Australia. So you blast freeze the goods first. That's a very energy intensive process. Then it's transported by truck, transported by boat, and then it lands in the US. And so near the port, there's another cold storage facility. And then that good is then transported to a manufacturing facility. Then that good, after it's manufactured, is transported to a distribution facility. Then it's transported again to a retail facility or maybe a food service business of some sort. And then it's consumed at home or maybe at a restaurant or whatever. I want you to consider the amount of energy intensity that you're looking at there. Refrigeration, number one, and also all of the transportation. Looking at GHG reduction in the cold chain is going to be a big effort over the next 20 to 30 years, and thermal batteries have a role to play, not only in the facilities, but also in the transportation as well. Next slide, please. Now, what is a thermal battery from a refrigeration standpoint? Let me just describe this to you. If you look at the image in the top right, that is those are thermoplastic cells mounted on a galvanized steel frame. They're only two parts. Very simple, very easy to install. And there's a mixture inside of the cells. It's salt and water. And the way it works, we basically have a facility, let's just say 0 degrees. We make a 5-degree formula. We put it in those cells at nighttime. The temperature of the box is 0. Again, the set point. We hit set point. Those cells are charged and ready to go. And then during peak period, of course, we're turning off the refrigeration and we're coasting. We're allowing that cold air to fall on the food, and it keeps the temperature stable in the room. So this is a great energy and demand flexibility application. The other application, and I want you to think about this, is public safety power shutoff events. And one recently happened in Hawaii, 12-hour public safety power shutoff event, and restaurants, a large number of restaurants lost all their food. And so the other advantage of this technology is if you have it in the facility and you have that sort of issue, whether it be an unstable grid or a public safety power shutoff event, it keeps the room stable, or as my clients say to me, when my refrigeration service company calls me at 5 p.m. and says, I can't make it there to fix your system until tomorrow morning, they sleep better at night because they know that their food is going to be kept safe. That's the idea. So the battery creates temperature stability. There are no mechanical components, no heat exchangers, no piping. It's a passive battery that just hangs in the space. The one on the bottom we use in a supermarket. We put it on the ceiling. The pallet that you see there, very often we use that in blast freezers to actually accelerate the freezing process. And again, we use wireless technology here to monitor the facilities so that owners have peace of mind in terms of their food is safe, and how much energy is being used, how much energy is being saved, et cetera. Next slide, please. And the benefits of a thermal battery, I'm sorry, the previous slide. Yeah, no, the previous slide. Thank you. And this is compatible with any refrigeration system. I've done, 0-degree boxes, for example, all the way down to 100 square feet and as large as 150,000 square feet. The system is pretty simple, and so it's designed with the materials that we're using to last 20 years. 100% round-trip efficiency, customer installable. The advantage of a thermal battery over lithium ion is this is 120 days for installation and commissioning. By the way, HVAC, thermal energy storage, you're talking about 24 weeks. Both methods of storage actually can be done in the short term. And I think there are a number of technologies required for demand flexibility on the grid over the next 30 years. This one is actually something that you can get in place quickly if needed. Now, Bloomberg NEF, New Energy Finance, did a study, and it's their inaugural study. And basically, they're going to be doing this every year. They compared 8 different storage technologies, thermal energy storage, along with compressed air and flow batteries and lithium ion. And they determined that thermal energy storage is the lowest cost, long duration energy storage battery today. And I think that's going to be there it's going to stay there for a while, because if you look at the levelized cost of energy for this type of battery, it's roughly speaking 2 cents to 5 cents per kWh over a 20-year life. If you look at a lithium ion battery, you're looking at 20 cents. So I think battery storage, I think there are 2 types again: thermal storage for thermal loads, electric storage for electric loads, and I think both are important. This qualifies again for a 40% tax credit. It's a U.S. made product. We support, for the most part, payback periods less than 3 years. Next slide, please. And I wanted to give you a taste of what this looks like. And the thing about the U.S. is this: every utility is different, their cost structures are different, their incentive programs are different. So if you have a cold storage facility, and let's say it's 150,000 square feet, that's not a small one, by the way, but it's not a large one. They get up to 800,000 square feet. The investment is about $474,000 after tax credits, and you're looking at a 2.1-year payback. And that's assuming a TOU tariff, and this is a very important point. To really maximize the benefit, you need a time of use tariff. Okay, without it, it's going to provide way different numbers in terms of the financials. And basically, in certain situations, and this is a very high-end utility, Xcel Energy, they're paying $500 a kW as an incentive for flexible load management, and that takes this payback down under a year. Now, that's one of the better scenarios across the U.S. If you are in California, there is no kW incentive. Unless you're in a muni, there's some munis that do pay a kW incentive. You're looking at roughly a 2.1-year payback in California. If you're looking at Tennessee Valley, okay, and I'm just contrasting here, Tennessee Valley, you're looking at 3 cents per kWh, energy charges, and you're looking at maybe $6.50 for a demand charge. Colorado, this example, is $19 per kW in terms of the demand charge. There, it's more like $6. So you're looking at a 3.5 to 4 year payback there. So it really does depend upon where you are in the country. For the most part, we're under 3 years just about everywhere. Next slide, please. And I'm going to wrap here and keep this to 12 minutes. That's my goal. And there is an efficiency bump that you do get with this technology, because at nighttime, refrigeration runs more efficiently. You might get a 10% efficiency, maybe 15%. You're not going to get much higher than that. This is not an efficiency tool. It is a load tool. It is ideal for demand management. There is energy cost reduction. There are tax credits. And by the way, that is a game changer for this technology. When I started with this technology 12 years ago, I was looking at 8-year paybacks. Okay, now the technology, we've made it better. We've made it simpler, lower cost. And the tax credits now, we're under 3 years, which is really great. Food quality, some people out there who are manufacturers, they care about their food. Will they sign up for demand response? Nope. They don't want to take the risk. With a thermal battery, they can. So food quality and resilience is what this battery can bring to the table. And of course, we do facility optimization by using software and by using wireless communication. And that's basically my wrap for this technology. I guess a couple of points to remember. First of all, 40% tax credit. Second of all, these batteries can be put in place in the short term, 120 days, 24 weeks. And this is part of the portfolio in terms of flexible load management from my perspective. So Laura, I'm going to turn this back to you. And I think Bruce is next.